In this video, we are going to know how an image is represented with pixels and the representation of an audio file and IP address. An image is represented by a tiny grid of elements called pixels. The more pixels in the grid, higher the resolution and clearer the image is. Each pixel represents a color. Colors are represented by using combinations of red, green and blue. Each color has a value ranging from 0 to 255. A pixel's color is represented by 3 bytes of data, one for each color. Here we can try setting the values for red, green and blue from 0 to 255. The total number of possible color combinations are 1,67,77,216. Now we are going to see how an audio file is represented. The most common way to represent a sound is to take samples of the sound at regular intervals, which is called sampling. The intervals in which sampling takes place is called sampling rate. It is measured in hertz. The most common sampling rates include 44.1 kHz. Higher the sampling rates, more the detail is. Bit depth determines the resolution of each audio file. It defines how many possible amplitude values each sample can have. Common bit depths are 16-bit and 24-bit. Encoding involves converting the sampled audio data into digital format that can be stored and transmitted. Lossless compression formats like FLAC and ALAC compress the audio without losing any quality. Lossy compression formats like MP3 compress the audio by removing some information, resulting in smaller file size but reduced quality. Now we are going to see the representation of IP address. An IP address, which stands for Internet Protocol Address, is a unique numerical label assigned to each device connected to a computer network. It identifies the host or network interface. It provides the location of the host for routing of data packets between devices. There are two versions of IP addresses. IPv4, which is the most commonly used version, it is represented as 4 decimal numbers separated by periods. IPv6 is represented as 8 groups of 4 hexadecimal digits separated by colons. Now we are going to look at sequence of first 20 numbers in base 2, base 4, base 6 and base 8. Now in base 2 or binary system, we use only 2 digits to represent all the numbers, which are 0 and 1. and the sequence of first 20 numbers go like this. In base 4 system or quaternary system, we use 4 digits to represent all the numbers, which are 0, 1, 2 and 3. And the sequence of first 20 numbers in quaternary system go like this. In base 8 system or octal system, all the numbers are represented by 8 digits, which are 0 to 7. And the sequence of first 20 numbers in octal system are these. In base 16 or hexadecimal system, all the numbers are represented by 16 digits, which are 0 to 15. Some 2-digit numbers are represented by alphabets. The sequence of first 20 numbers in hexadecimal system are these. Now we are going to see how to convert a number in decimal system into binary, quaternary, octal and hexadecimal system. Now let me tell you what a number system is. A number system is a method of representing numbers with digits. The number system we use daily is called decimal number system. All the numbers in decimal number system are represented with 10 digits, which are 0 to 9. In binary number system, all the numbers are represented with 2 digits, which are 0 and 1. Now let's see the conversion of a decimal number into a binary number. Let's take an example 41. If we are going to, now we'll take 41 as an example. Let's convert this into binary system. We have to divide it by 2. We have to write these numbers in this order. Now we are going to take an example 49 and we are going to convert it from decimal system to binary system. As we are converting it into binary system, we have to divide it by 2. And we have to write these numbers from bottom to top. To convert this binary number back into the decimal number system, we have to multiply each digit by 2. The powers to the base increases by 1 towards the left for integer part and decreases by 1 towards the right for the fraction part. We got the same decimal number. Now let's take another example. Let's take 107. The binary number representation of 107 is this. To convert it back into the decimal system, let us see the conversion of a decimal number into a quaternary number. Let's take a number 74. We have to divide it by 4 as we are converting it into a quaternary number. To convert it back into decimal system, let's take another example. Now let's convert a decimal number into hexadecimal number. We have to divide it by 16. Now let's take an example 255. Now when we have a remainder which is a 2-digit number, we use alphabets to represent them. A for 10, B for 11, like that. Now as per this, we are going to represent 255 as FF. Now let's take another example. 90. Now we have one digit number and a 2-digit number. We are going to represent this as 5A. And to convert this back into decimal number, it follows the same rule. A represents 10. Now let's convert a decimal number into octal number. We have to divide the number with 8 this time. Now let's take an example 127. Let's convert this back into decimal numbers. Let's take another example.